Hi guys, welcome to CodeWise, and today we are back again with the question called combination sum. It's a medium level question in code, and this is very much similar to the question called subset, which I have already done in the in our channel. Do check that out, please, if you want to understand this question better. Because in this question, directly I'm going to start with the code and explain you the concept. So do check this video out for better understanding because we are using backtracking here. Uh, uh, the approach was same in this also. If you want to know the concept, you can just check this video. So let me just directly let's first read what's the question. So question is they have given the candidates array with a given target, so we have to find the sub-array which has a target of 7. In this case, 2 plus 2 plus 3 forms 7, so that is one sub-array, and repetition can occur. That's fine. One element can repeat more times. That's fine. So that's not a problem in this. So it's fine. So 2 to 3 will be one array, and 7 will be one array. So we are just outputting it. So this is what we have to find. So as I said, we are using backtracking here. For that, the basic approach, just let's take two vectors. That is why we are taking two vectors, because we need something to hold the subarray, and we need something called vector of vector to display the array output. This answer displays the output. Why is we use the subarrays which are stored in this vector, right? So at end we are just returning the answer. This is what we have to return. Cool. So we are just taking the helper function called solve, and we say that let's take this as c, let's take this as t, let's say that ct, and let's keep 0. I'll say why we are taking 0, because we need a iterator. Let me just show you, let me just code, and you'll understand on your own. So we are taking a, see, always remember, whenever if you're going with the DFS or the backtracking approach, always just use void as your data type, because it's more efficient. That's a common practice that we follow. It's not necessary though, but it's more easier if you're using this. And yeah, so vector, why are we writing this? We can copy this. Sorry. So let's take something like idx, and we say that since we are iterating it, we are using recursion, that is backtracking. So we say that if t less, it's a base case, if t is less than 0, if t goes less than 0, just return. We are saying why we are taking t, because we are checking if t double equal to 0, we say that answer dot push back v. Let me just explain, don't panic. So what we are doing is, so I think when I say t equal to 0, you might get some concept. Because what we are doing is, as we are iterating, we know that when it is 7, if you are minusing 2, it will become 5. And if you are minusing 2 again, it will become what? It will become 3. And 3 minus 3 will be 0. So we know that when t will be 0, we get the target sum, that is 7, right? Right or wrong? Right. So as we know that we have stored, like we are going to store the subarray in v. So when we find that we got target that is equal to 0, that is nothing but target equal to 7, we just store this subarray into the answer vector. I hope you get it. So we are just taking a for loop which iterates from idx and I less than we say c dot size and I plus plus. In this, what we do is we push back c of I, that is the element, and we say that go solve c t minus c of I. This is what we discussed, right? We as we fill in the c element, that is the elements inside the v, we decrease simultaneously, and we also see we don't increase I value, because as we know that 2 can repeat also, right? 2 can be repeated, so we are just leaving it as I, because however this is iterating, right? It's going to increase, so we are keeping it as I itself. So, and this is the main concept, that is backtracking, that is we pop back. Why we are popping back? In case if this is going gray less than 0, or if the condition is not for satisfying, so we have to pop back, right? For example, let's take an example, like if you are taking 2 2 3, and let's take some other example, like let's take we are taking 2 6. 2 6 is greater than this one, right? 7. So if it is greater than 7, we have to pop that back. We don't want 6. 2 is fine. We have to pop that back. So we remove 6. Again, we start iterating from 2. That's what pop back does. That it pops back. That is, it removes element. If it is satisfying, it adds, or else it removes. That's what this pop back does. So I hope I think we are done with everything. Just let's run this. Yeah, it does work. See, yeah, let me just explain you once more. So what we are doing is we are taking the helper function. We are returning answer. As I said, it's going to return the output. Why we are taking b is a sub array in this answer, so we are taking we are pushing back v when t equal to 0, that is when we find the target. When we get the target equal to 7, we just push v to the answer, because we know that the sub array is stored in v, right? We know that 2 2 3 is stored in v, so if it is equal to 7, we just push that into answer subset and we return it. So, and that is the base case, and we are just iterating, pushing each element and just trying if it is equal to t equal to 0 or not. We push each element and we just minus it and go again, and we check if it is not I mean, if it's not equal to, or if it that is less than 0, that is if the target is more, and if target is more, the t will be less, right? Because we are minusing it, right? So if, for example, if t is t target and minus c of I is greater than t, it will be in negative value, right? If that is the case, it will return and it will again pop back. It will pop back, and again we will start with routine. So that's a concept. So let's run this. It does work. So that is all from this video. If you like the video, if you like the content, or like the video, to subscribe to our channel. And there are a lot of other videos too. Do check the videos and also check the subset some for more understanding of this problem. So yeah, stay tuned, stay coding, be safe. Thank you.